Every time I sit down to architect a decentralized application, I'm reminded of a lesson I learned early in my Web3 career: the smart contract is the heart, but the frontend is the face users actually trust. Over the past 2 decades in IT, and especially through my recent work on Stellar's Soroban platform, I've refined a repeatable blueprint for shipping production-grade DApps. Let me walk you through it. Designing the Soroban contract architecture. Soroban, Stellar's smart contract platform, runs on Rust compiled to WebAssembly. This gives us near-native execution speed and deterministic behavior, critical for financial tokenization use cases where I've seen a single non-deterministic call corrupt an entire ledger state. My architectural rule is simple: separate storage, logic, and access control into distinct modules. Here's a minimal token contract skeleton. Notice Soroban's built-in authorization framework. In a tokenization project I led, this native primitive eliminated an entire class of signature replay vulnerabilities that plague EVM contracts. I always recommend using instant storage for global config and persistent storage for user balances, since instant storage has TTL costs that scale with contract size. One concrete data point: on Stellar testnet, a well-optimized Soroban transfer costs a fraction of a cent and confirms in roughly 5 seconds, versus the multi-dollar gas spikes I've measured on congested layer 1 chains. Bridging contracts to a Next.js frontend. The connective tissue between Soroban and the browser is the combined with wallet integration via Freighter. In my Next.js projects, I isolate all blockchain calls behind a service layer so components never touch the SDK directly. The pattern I insist on with my teams is simulate before submit. Soroban's returns the resource footprint and auth requirements, letting you fail fast in the UI before the user signs. This single practice cut our failed transaction support tickets by nearly 70% on one client dashboard. On the React side, I used to cache read-only contract state, treating the ledger like any other async data source. This keeps the interface responsive and avoids hammering the RPC endpoint on every render. Security, testing, and deployment discipline. A DApp is only as strong as its weakest untested path. Coming from a digital forensics background, that is, my own methodology treats every contract as a potential crime scene, assume it will be attacked and instrument accordingly.